All right, function notes. So this is the new topic. Today we are talking about functions and what they represent. So we have some vocabulary here. The vocabulary that we have would be the x values we already know, but whatever I write, I expect you to write unless I say, hey, don't write this. All right. So this topic is not hard. It's really simple because a lot of the stuff we've already done before. So x values are called the input values. We have done this. We just never called it this before. The y values are called the output values. We have seen this. We've just never called it the output values before. But this is new. This is new. This is new. A relation is a set of ordered pairs. Again, a relation is a set of ordered pairs. So when I ask you tomorrow, what's a relation? It's a set of ordered pairs. You know what? I just had a thought. I'm just going to do like a small little pop quiz on this topic. That's what I'm going to do. That's what I'm thinking I'm going to do. All right. A relation is just a set of ordered pairs. That's what a relation is. A relation is. A function rule, yeah, we've seen it before, but we haven't really called it a function rule, is the expression that produces the y values. And all of this is going to make sense. This word relation and function rule is just about to make sense to us. So what is a function? A function is a relation. Watch this. A relation, which is a set of ordered pairs in which every x value has only one y value. It's going to make a lot of more sense. A lot of more sense. Is that right? A lot of sense. Yeah, that's the what I should say. Okay, a relation in which every x value has only one y value. So what's a relation? A set of ordered pairs. So I can say a function is a set of ordered pairs where every x value has one and only one y value. We can see how a function forms from the function machine below. So this is what I call the function machine. It's just a fancy way of whatever. Okay, this is the function machine below. Consider y is equal to 2x plus 3. So we've seen this. This is in slope-intercept form. We have seen this. This is in y is equal to mx plus b form. Nothing new about that. Nothing new about that. So we have seen these. So when I input 1 into the function rule is the expression that produces the y's. So what's the expression that produces the y's? This is my function rule. My function rule is the expression that produces the y because y is equal to whatever 2 times x plus 3 is. So when I input x value, again, vocabulary is very important for this unit. When I input my x value into my function rule, which we've done before when we solve systems, when we input my function rule of, when I input my x into my function rule of 2x plus 3, my output, which is my y value, is 5 because 2 times 1 is 2 plus 3 is 5. When I input 2 into the function rule, this is the function rule, remember, this is the function rule, is the expression that produces the y values. The expression that produces the y values is 2x plus 3. So when I input 2 into the function rule of x, input 2 into the function rule of 2x plus 3, I get 2 times 2 plus 3, which is 7. Input 3, I get 2 times 3 plus 3 is 9. Input 4, I get 2 times 4 plus 3 equals 11. This says, why is this a function? So, what is a function? A function is a relation in which every x value has only one y value. What's a relation? A relation is a set of ordered pairs. So, if I have an x and a y, that means I have a set of ordered pairs. What are the ordered pairs? We're going to write this down. The ordered pairs are 1, 5, 2, 7, 3, 9, and 4, 11. So, okay, so a function is a relation in which every x value has only one y value. So let's talk about this. Does this x value have only one y value? Yes. Its y value, let me make this smaller. Gotta lose a little weight, buddy. Its y value is 5. Okay? You don't have to do the highlighting. Just watch me highlight. Oh my gosh. Hold on, y'all. I don't know what's going on with my video. It's up here acting weird and stuff. All right, there we go. I don't know why that message comes up. I don't know. It's going to keep coming up, but whatever. Does this 2 have only one y value? Yep, the 2 only has a 7. Does this 3 have only one y value? Yep, it has 9. This 4 only has one y value. Yep, it has 11. That means 1 can't have another y value. If it's mapped to 5, it's like y'all, relationships. It's like relationship, you know what I'm saying? If 1 goes with 5 and only 5, it's faithful to 5. Can't break up. Well, you can break up, but you just can't go with nobody else, right? So it's like a marriage. All right, so sort of, divorce is kind of high in the United States. Let's go back to this point before I get off this subject. So what is that saying? That is saying simply that 1 can only have 5, 2 can only have 7, 3 can only have 9, 4 can only have 11, because a function is a set of ordered pairs, a relation, in which every x value has only one y value. So is this a function? Yes, it is a function. Why is it a function? Because every x value has only one y value. That's it, y'all. That's what a function is. Telling you, it's going to be simple. Told y'all. Think I'm playing. All right, so it says use the function rule to build the outputs for the given inputs. Are the following equations functions? So let's see. So my function rule is the expression that produces the y, which is my output. So my function rule here is x squared plus 3. So this is where people get in trouble. When I put in -2, I am squaring -2, and then I'm adding on 3. A -2 squared is a -2 times -2, which gives you a positive 4. 4 plus 3 is 7. Okay, when I put in -1, -1 squared is -1 times -1, which is 1. 1 plus 3 is 4. When I square 0, again, I'm putting my input into the function rule right there. When I square 0, I get 0 squared plus 3, which gives me 3. When I square 1, 1 times 1 is 1 plus 3 is 4. When I square 2 squared plus 3, 2 squared is 4 plus 3 is 7. So the question asks, is this a function? So let's see. Does -2 have anyone else but 7? No. -2 only has 7. -2 does not have 4, does not have 3, does not have 4, does not have 7. -2 has 7. Does -1 have anybody other than 4? No. -1 only has 4. Does 0 have anybody other than 3? Nope. 0 just has 3. Does 1 have anybody other than 4? Nope. 1 just has 4. And then this is where people get confused. Does 2 have anybody other than 7? Nope. 2 only has 7. Because what happens is that y can have other people. But x can't. Okay? So you can have repeating y's. You just can't have repeating x's. -2 only has 7. That's it. -1 only has 4. 0 only has 3. 1 only has 4. 2 only has 7. Yes, 2 has 7 and -2 has 7, but 2 only has 7 as a y. -2 only has 7 as a y. So it's very important that we're going to talk about this in a second because I want to make sure y'all understand this. All right, so let's come over here. I know I could just shut off my mid-thought. So what's the function rule? The function rule is take my x, the absolute value of x, and then add 2. And that's how I end up with my y. So this is my function rule. Take the absolute value of x and then add 2. So the absolute value of -2 is 2 because 2 is away from 0. That's why absolute value is always positive. 2 plus 2 is 4. The absolute value of -1 is 1 because -1 is one place away from 0. Therefore, the absolute value of -1 plus 2 is 3. Absolute value of 0 is 0 because 0 is 0 places away from 0. So absolute value of 0 plus 2 is 2. Absolute value of 1 plus, put this little 1 like that, plus 2, 1 is 1 place away from 0. 1 plus 2 is 3. Absolute value of 2 plus 2, 2 is 2 places away from 0. 2 plus 2 is 4. Is this a function? Does -2 have anybody other than 4? No. Does -1 have anybody other than 3? No. Does 0 have anybody other than 2? No. Does 1 have anybody other than 3? No. Does 2 have anybody other than 4? No. Is this a function? Yes. Both are functions. Why are they functions? I'm about to give y'all the simplest way to figure out if it is a function. So, if x repeats, it's not a function. Why does that make sense? Because x can't have anybody other than the one person it's mapped to, and then in this case, the one output that it's mapped to. So, if negative 2 has 7 and negative 2 has 4, this is not a function. Not a function. Why? Because negative 2 can only have 7. You can't, no, negative 2, no, negative 2. You can't have 4. I know life is not fair, but negative 2, the x's cannot have anyone other than the one y that it has. All right? We're in this for life. Okay? So therefore, it's not a function because negative 2 can only have 1 and only one y. So if the x's repeat, is not a function. What did I just say? If the x's repeat, is not a function. What did I just say? If the x's repeat, it is not a function. What did I just say? If the x's repeat, it is not a function. So what is a function? A function is a set of ordered pairs where the x's cannot repeat. What is a function? A function is a set of ordered pairs where the x's cannot repeat. What is a function? A function is a set of ordered pairs or a relation where the x values cannot repeat. All right, so this question asks, why would most equations be functions? Give you a moment to think about it. You can pause it. I know you're probably not going to pause it because, you just like, I just want to get through this video. All right, so why would most equations have a functions? Because when you input, you always get a different output. That's why most equations will have functions. When you input a number, most equations give you a different output. You know what I'm gonna do for extra credit for a homework pass? Anybody that can come up with an equation that involves y and x, that's the key, y and x, that gives you the same output for the same two different outputs for the same number, I'll give you a homework pass if you come up with one. All right, that's that. So this is where people get confused, especially on the EOGs, and I'm about to be done in the next, 10 minutes. All right, the word linear and function are not used interchangeably. Okay, that means you can't switch them back and forth. All right, in order to be linear, the what? Rate of change must be constant. Rate of change is slope. In order to be a function, the x values cannot repeat. They are not the same. Okay? So in order to be linear, the rate of change must be constant. In order to be a function, the x values cannot repeat. They're totally different. So if I'm asking if something is a function, I'm asking, does the x values repeat? If I'm asking if something is linear, then I'm asking, is the rate of change constant? They are not the same. So, are the following tables linear? Are they functions? Explain your reasoning. So, let's start with linear. How do we find rate of change? Rate of change. Yes, you're writing this down. Change in y over change in x. And rate of change is the same thing as what? Slope, which is rise over run. Box, these don't look like I'm dividing rate of change by changing y. All right. So, 0 becomes 7 by adding 7. 7 becomes 10 by adding 3. 10 becomes 14 by adding 4. 14 becomes 25 by adding 11. 3 becomes 4 by adding 1. 4 becomes 5 by adding 1. 5 becomes 4 by doing what? Subtracting 1. And then 4 becomes 10 by adding 6. So let's talk about rate of change. So the rate of change would be 7 over 1 and then 3 over 1. There clearly it's not linear. So this is not linear. Is it a function? Well, let's see if the x values repeat. 3 has a 1, 0. 4 has 7. And 4, Lord, 4 is cheating. 4, y'all see that? 4 is cheating. 4 is cheating. No cheating. Sorry, buddy. You know why I discourage? Let me go on this tangent. You know why I discourage relationships at such early ages? Because y'all learn how to just not be faithful and cheat, and it just goes on. When you get older, you don't really know how to be faithful because you started in middle school and you wasn't faithful then, and then when you get old, like 25, you've just been cheating all your life, and all you know is cheating. Now you want to settle down with somebody and you don't know how to settle down because all you did for the rest of your life was a cheater. So that's just that. That's my philosophy. I just slide that in there. All right, so it's not a function, so not linear and not a function. That's that. Let's look here. Rate of change. Adding 1, and it's like we're adding 1 all the way down. So I'll just do that for the sake of time. Okay, on my x's, adding 1, looks like we're adding 1 all the way down. Okay, so what's the rate of change? The rate of change would be 1 over 1. Is it linear? This is linear. Linear. Okay, is this a function? Well, let's look. 1 goes to 1, 2 goes to 2, 3 goes to 3, 4 goes to 4, 5 goes to 5. Man, nobody's cheating. Function. X's do not repeat. Simple as that, people. Ooh, this video is going to be longer than I thought. All right, 5 to 3. I guess I'm over here trying to preach to y'all about relationships. All right, subtract 2, and then I add 1, and then I add 3, then I subtract 3, and then over here I'm adding 1. Looks like I'm adding 1 all the way down. So the rate of change would be negative 2 over 1, and then 1 over 1. Well, we know it's not linear. Is it a function? I need to read that error message. Maybe I'll learn what my computer is doing. All right, is it a function? Well, negative 1 goes to 5, 0 goes to 3, 1 goes to 4, 2 goes to 7, 3 goes to... Nobody's cheating. So this is a function. It's a non-linear function, but it is a function, y'all. It is a function because the x values do not repeat. It's a function. What about the next one? 1 goes to 4 by adding 3. 4 goes to 9 by adding 5. 9 goes to 16 by adding 7. 16 goes to 25 by adding 9. Nice little pattern here. But over on this side, we're just adding 1 all the way down. So we get 3 over 1. Then 5 over 1. Well, clearly this is not linear because the rate of change is not constant. So this is non-linear. Let's see if it's a function. 1 goes to 1, 2 goes to 4, 3 goes to 9, 4 goes to 16, 5 goes to 25. Whoa. So it is a function. It's just a non-linear function. Why? Because the x values don't repeat. I think y'all are intelligent. Y'all have come so far. Look at y'all. So again, a function says that every x value has to have only one y value. In other words, x's cannot repeat. They can't cheat. Repeat, cheat. Repeat, cheat. X's can't cheat. Are the following graphs functions be able to explain your reasoning? All right, so here, if the whole purpose is to say, I wanted you to do it on your own. I wish I was there to teach this because, it'll make more sense, but it is what it is. I'm not there, so I can't. All right, so let's look at this graph. If a function is a set of ordered pairs, and we clearly have a set of ordered pairs, you don't have to, box the graph. We clearly have a set of ordered pairs. Do we have any repeating x values? Let's look. So nope. Let's get a highlighter. No repeating x values there, 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 none here, none. Wait a minute, right here. The x values that repeat here are negative 1, 2, well, yeah, negative 1, 2, 3, 4. So this has negative 4, 1, 2, 3, and this has negative 4, negative 1. We found a cheater. You can't be a function. You know why? Because the x values repeat. Not a function. Not a function. What about this? All right, well, if I look at the x values and I just go across the x values like this, None of them are repeating. None of them. You just have, that's one x value, one x value, one x value. I mean, none are repeating. So this is a function. Function. What about this bad boy right here? Looking all fancy with this z. Sir, I have a problem. So if I even look at the y-axis, I have repeating x values all over the y-axis. 0 is here, 0 is there, 0 is there. I mean, there's a whole bunch of cheating going on here. Look at this, y'all. Look at this craziness. Do you see this craziness? This thing, just worrisome. Look at all those x values repeating. This is clearly not a function. Just bold with it. So what did I do? What do y'all see? What kind of lines do you all see on my, I'll read you later one day in my life. Okay, what type of lines do y'all see on my graph? Vertical lines. So I'm hitting at something. So we use the vertical. Ooh, that's an ugly vertical. Goodness, let's do that again. Vertical, and it's not CLE. Somebody will spell it like that every year, like 10 people spell it like that. The vertical line test to tell if, that's supposed to be if, graphs are functions. The vertical line test is used to see if x repeats. If the vertical line touches the graph more than once, then the graph is not a function. We can see this, right? So sometimes this is called the pencil test. You just take a pencil and you just run it. I wish I could do that, but I can't do this with this software. You just run the pencil across along the graph, like from here to here, just vertically. And if it touches more than one place, it's not a function. So if we do vertical lines, we can see that it fails the vertical line test because the x's repeat here, here. The x's repeat there, there, and there. The x's repeat there, there, and there. So in order to pass the vertical line test, you can touch the graph only once. So touch the graph once to pass. So this is why this was a function, everybody, because that vertical line touch once, touch once, touch once, touch the graph once, touch once, touch once, touch once, touch once. Because if it touches more than once, it is saying what? The x's repeat. And if the x's repeat, it is not a function. So we're about to be done. I think we're going to be done by 25. You have your life back, and you have your intelligence increased. Beast mode, son. Get on my level. All right, great. Okay, so let's look. Vertical line test. So if I make a vertical line here, wait a minute. 3, you're a cheater. Right here and right here, this is not a function because the x's of 3 and 3 repeat. And we found another one. This one's bold. -2 and -2 repeat. You're not a function. Let's use our vertical line test. If you take a vertical line, I wish I could. You just run it across it, but I can't. I might. Let me see if I can. Well, you look at here. I can't run this vertical line across. Boy, but it's not vertical. It's like diagonal. Let me see if I can draw it. Whatever. We're not going to go through all of that. Y'all get the point. All right. No, not a pencil. We want a vertical line. All right. That's straight enough. Okay. So take the vertical line, run it through. Don't play with me now. Move. You don't want to move anymore? Okay, so run the vertical line through. Hold up. Hold up. Found a cheater. You're not, wait, there's another one. Not a function. Wait, then I missed one down here. Clearly, you're not a function. Goodbye. Okay, let's take our vertical line. Move it along here. Come on, move, buddy. I need you to move. I need you to act like you're supposed to make me look good. Make me look good. You don't want to make me look good. I look good anyway. Ha. Play yourself if you want to. All right, whatever. Vertical line, vertical line, vertical line, vertical line, vertical line. Nobody, no one is cheating. You are a function. No x's are repeating. You passed the vertical line test. You only hit one dot one time. All right, right here. Look at here. Look at here. Look right in there. You little cheater. You're not a function. Now, people get confused on this one. I wish this vertical line would work so I can show y'all what I'm talking about. Maybe if I need to gain it, put a little weight on it. Let me put a little weight on this vertical line, y'all. Watch this. Fatten it a little bit. It's Thanksgiving. Ooh, that's too big. But whatever, y'all get the point. Never mind. It won't do all of that. Ain't nobody saying all of that. No. All right. Well, whatever. Stuff ain't working right. Just work with me. It is what it is. All right, cheater. Now you really acting up. Hold on. Let me pause the video. All right. So, yeah, like I was saying, we got a cheater on our hands right here, everybody. There is an x value of 2 there, and there's an x value of 2 there. You're not a function. Right here, people get confused easily. They are looking like they're about to meet, but they don't meet at the y-axis. So this is a function. Okay? And I'm gonna hurry along because I've been really talkative this morning. All right, so let's look at this one. Vertical line test. Do you touch more than once? Do you touch more than once? Some people are talking about the tip of the arrow. It cracked me up every year. No, you are a function. You don't cheat. No cheating there. Vertical line. Do you touch more than once? Do you touch more than once? Nope, you don't touch more than once, buddy. You are a function. What about this one? Vertical line. Well, you look at here. Look at all this mess that's going on right through there. All this cheating going on right in here. Right up in here, y'all. Y'all see this? Right up in here? Look at that right there. You're not a function. Be faithful. That's all people want. Just be faithful. You know what I'm saying? Just be faithful. Vertical line. You pass. Function. Vertical line. Vertical line. Looks like y'all want to touch here, but you don't. You pass. Function. Vertical line. Vertical line. Vertical line. Vertical line. You pass. Function. All right, folks. That's it. That's the entire lesson. I know you had fun. Great. I know I'm amazing. You are too. We all are just amazing. We're just amazing creatures, amazing people. You know, we're just amazing. All right. You know I'm about to do this. This has been another Beast Mode production. This is Mr. O'Neal. I'm signing off. Have a wonderful life. I'll see you tomorrow. Goodbye.